All right, I want to use parametric equations to draw a smiley face. So first I've just drawn my smiley face, and then I got to put it on a coordinate system. So I'm gonna just say there's a coordinate system where the x-axis is running through there, right through the middle, and the y-axis, what just happened? The y-axis is running right down through here. Okay, there's my x-axis, there's my y-axis. This lets me get an idea of how big this thing is going to be. So I look at this and I see there's four curves that I need. I need the outside circle, two eyes, and the mouth. Okay, so let's do the outside circle first. The outside circle here is looks like a big circle. Now I can just say, well, I know how to do circles, or I can say, well, maybe I can't remember how to do circles. So the thing that I'm going to do is I'm going to draw a couple of quick graphs here. And what I'm going to do is I'm going to think about this circle in terms of animate it. That is, draw it by saying, I'm going to start at a particular spot and go around. And I'm going to draw here two graphs, x versus t and y versus t. Right? So the x-coordinate, let's start right here and draw this circle going this way. So the x-coordinate is going to start up at 7. This looks like 1, 2, 3, 4, 5, 6, 7. Yeah, that's 7. So it's going to start up at 7. And then as I go around, it goes down to 0. It goes down to -7. So it goes 7, down to 0, down to -7, back to 0, and back to 7 again. That's what just the x-coordinate does as I go around. Right? Now, what does the y-coordinate do? Well, at the same time the x-coordinate did that, the y-coordinate started at 0, climbs up to 7, comes back down to 0, goes down to -7, and back to 0 again. So that the up and down part of that, or the sideways, was doing this thing, 7 to -7, back to 7. The up and down part is going 0, up to 7, back to 0, down to -7, back to 0 again. Right? And I look at those two things and I say, hey, that first one looks like x equals 7 cosine t, and the second one looks like y equals 7 sine t. And in that way, I have myself a nice circle. Okay. That's equations of a circle. Let's look at the left eye. The left eye is a circle of radius 1, maybe here. If I do the same kind of analysis, which I'm going to do here, I look at x versus t, and I look at y versus t. Right? Again, let's start. I find it easiest here to start there. So the x-coordinate starts at, what's the x-coordinate start at? -2, -1. So actually, let me do this. It's going to start at -1. Slide that up there. So the x-coordinate starts at -1, goes all the way down to -3, and then comes back up to -1 again. So it's here, drops down to -3, and comes back up to -1. Right? Boy, that looks to me like, so this is -1, -3. This looks like, this is x, this is t, so I've got x equals, well, it's amplitude 1 cosine curve, but it's been shifted down 2. Right? And notice that the center of that circle is at -2. And then you do a cosine above and below it. Okay? The y-coordinate at the same time is starting at 3. So let's take this and slide it down some. The y-coordinate is starting at 3, going up to 4, so it starts at 3, goes up to 4, goes back down to 3, goes down to 2, and goes back to 3 again. So that looks to me like y equals, well, it's been shifted up 3, and it's a sine curve. Okay. Notice, the cos t sine t would just be a circle centered at the origin. but the x has been shifted by 2 to the left, and the y has been shifted by 3 upwards. And hence we get those parametric equations there. Okay. The right eye looks very much the same as the left eye, except that the center is over at positive 2, comma 3. So where this was the face, this is the left eye. The right eye, I'm pretty confident I can just say, this is I, x equals positive 2 plus cos t, y equals 3 plus sine t. And then we've got that, the smile. Well, the smile looks like just part of a circle, maybe centered at the origin. Radius 1, 2, 3, 4. Well, if I've got the mouth here, looks to me like it's going to be a 4 cos t, 4 sine t. Right? Let's see if we can put that on the computer and see what it looks like. Alright, this is from the online graphing calculator on my website, faculty.watcom.ctc.edu/wweber. Go to the online live math resources and click on the graphing calculator. This is set up to look a little differently here. It's parametric equations, but it's entered kind of like a vector, whatever those are. I'm going to put the x coordinate here. So for the face, let me open up the window here so I can see that. All right, there we go. So for the face, I wanted, this is parametric curves, okay. I wanted 7 cosine t for x and 7 sine t for y. Let me click on that and see. All right, so there's the outline of my face, right? Then I need the left eye, which we said was -2 plus cosine t, comma 3 plus sine t. There's the left eye drawn in blue, apparently. One thing to notice on these parametric equations, the way I have it set up, is dot 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 underneath here, which means there's something hidden. This is actually, I have it set so that I can change Tmin and Tmax. So for instance, on the outside circle, if I just go from 0 to 1 times pi, then it only draws the first part of it. Right? Just say go from 2 pi, goes all around. So built in here are each one you can change what t values you use for the different curves. But since I wanted to draw the full circle, I think that's it's good to go from 0 to 2 pi, not 121. What the heck was that? Let's go just to 2 pi. There we go. That's good. That's good. The next one I want very similar to the previous one, but this is +2 plus cosine t and 3 plus sine t. And double check. Oh, there it is in red. And the smile was, I think we said it was a radius 4 circle, so 4 cosine t, 4 sine t. And I don't want the whole circle, do I? So what I want here is I just want the bottom half of it. So let's just go from pi to 2 pi. There we go. There we go. Right, on that last one, I'm plotting not the whole circle, but just from pi to 2 pi to get that. And there's my smiley face. Yeah, I'm going to do a couple of things. I want both eyes to be blue, so down here, the red one, I'm going to say don't make it red, make it blue. Alright, and the mouth looks funny green. We actually want the mouth to be red, because lips are red, of course, right? No, they're not actually always red, just sometimes. There's a nice smiley face. You could do things like say, I think he's got way too much of a smile. Maybe I really only want to go from, uh, let's go 5 pi over 4 to 7 pi over 4. Yeah, a little more under control smile. Sometimes we have smiley faces that wink, so rather than drawing one of those eyes as a circle, let's draw it as a straight line. Interesting thing here is that if I think about just taking this sign, so I don't want the y value to go up and down at all. I just want to draw a line segment back and forth here, no vertical up and down. So I need it to stay at 3. So if I just delete this part right here, so what I have is 2 plus cos t for x and just a 3 for y. So the x is going back and forth between 1 and 3, and the y value is just staying at 3, and you get that line segment. So there, I've got my winking smiley face. Yeah, there's all sorts of things that we can do by just some variations on the theme here. One last one. Let's put this, let's get him wide-eyed again. And let's make him look surprised. So let's do a full circle on the mouth down here. Well, what the heck was that? 0 to 2 pi. But that's too big a circle. So let's shrink it down. Well, that's interesting. Let's shrink it down some. And let's slide it down. So let's shift it down here. Now he looks surprised. Actually, his eyes should be open wider. So let's make the y values of the eyes have a little bit more amplitude. Let's say times 1.5. Oh yeah, that opens his eye up a little bit. Let's this one times 1.5. I didn't change the center. I just changed, and I didn't change the x coordinate. I just changed the y coordinate, the amplitude of how much up and down it has. Right? And so I've got him wide-eyed, open mouth, surprised, right? I chose to make the mouth an ellipse by using a 2 and a 3. I could have a complete circle mouth by keeping the amplitudes the same on both of those. I don't know, I think we emphasize the amount of surprise by opening that mouth a little wider. Anyway. I'm just having fun, and really, I can't emphasize enough to you to have some fun too. Try some things, see what you can do. Play with some different functions and see what you can get out of them. There's a lot of stuff that we can do with parametric equations.